What if the sun just blinked out of existence? Just for a second. Would you feel it? Would the Earth go flying off into deep space? Would plants instantly die? Or your phone just stop working? 1 second seems short, but in space, even that could rewrite everything. The sun. You probably don't spend much time thinking about the sun unless it's blinding your eyes on a morning commute or you're soaking up a beach day. But that blinding ball of fire 150 million kilometers away, it's literally holding your life together, not just your tan, your food, your sleep schedule, or your climate, your entire existence. Without it, there's no weather, no gravity-bound orbits, no daylight, no warmth, and yes, no Wi-Fi towers either. But what if it just disappeared, for a single second? Now this might sound like a cosmic joke. How could the sun just vanish like a faulty light bulb? But let's set that aside. Assume for a moment that for precisely 1 second, the sun, light, gravity, solar wind, all of it, just wasn't there. What happens to you? To Earth? To everything we know? Let's walk through it, second by second. Light travels slow. Well, relatively slow. Here's the twist. If the sun disappeared right now, you wouldn't even notice, not immediately. Light travels at 299,792 kilometers per second. So the sunlight you're basking in, it's already old news. Over 8 minutes old to be exact. That's how long it takes photons to cruise across the vacuum of space and land on Earth's face. So if the sun stopped shining, it'd be like pausing a live stream. You'd still see it, bright and unchanged, for another 8 minutes and 20 seconds. For that 1 second it's gone, nothing visually changes here. The sky doesn't suddenly go black. You keep walking, scrolling, yawning, unaware that a cosmic event just glitched out. But there's more than just light involved. Gravity travels at the speed of light too. Gravity. It's not just keeping your feet on the ground, it's what keeps Earth spinning in orbit instead of flying into the void. And here's a wild truth. Gravity, according to Einstein's general relativity, travels at the same speed as light. So if the sun's mass stopped pulling on us for 1 second, we wouldn't feel it, not yet. Just like light, gravity has a delay, so Earth wouldn't immediately be flung into space. For that second the sun is gone, Earth still feels the sun's tug like nothing happened. The gravitational influence that's holding us in our perfect elliptical orbit, it's still in play for 8 more minutes. But after that second, after the sun flickers back into reality, the stream of gravitational data continues as normal, as if nothing ever interrupted it. Okay, so what changes in just 1 second? At first glance you might think, well, nothing. And on the surface, that's kind of true. You wouldn't feel colder, the lights wouldn't go out, gravity wouldn't shift, and the birds wouldn't stop chirping. But zoom out, there are ripple effects that creep in, and some are sneakier than you think. Solar wind takes a breather, and cosmic radiation takes its shot. Here's a part of the sun you probably haven't thought about: the solar wind. It's an invisible, constant stream of charged particles the sun throws at the solar system like a hairdryer on full blast. That wind does more than just give astronauts headaches. It shields Earth from cosmic rays, the high-energy particles zipping around from exploding stars and black holes. When the sun disappears, even for just 1 second, that solar wind stops too, and while the Earth's magnetic field does a solid job as a backup bouncer, deflecting most of the nastiest stuff, a second-long gap in solar wind protection could let in a burst of extra radiation. Would you fry? But electronics in orbit, like satellites, communications arrays, even space telescopes, might hiccup. A bit of unexpected radiation could cause minor glitches or signal interference. Nothing apocalyptic, but in the delicate dance of satellites and sensors, even a blip can matter. Photosynthesis, barely a bump. Plants need sunlight to survive. That's basic science. But here's the thing, they don't freak out over 1 second of shade. A cloud passes overhead and trees don't drop dead. So during that single second of darkness, which we won't even see until 8 minutes later, nothing changes for Earth's plant life. Photosynthesis pauses, then it resumes, like flipping a light switch too fast to notice. Temperature? Still toasty, for now. What about heat? The sun is a giant furnace, right? Surely a second-long pause means the planet starts cooling, right? Not even close. Earth's atmosphere acts like a gigantic thermal blanket. It doesn't just vanish when the sun takes a brief break. The heat trapped in the oceans, the land, and the air doesn't have time to escape in a single second. Your morning coffee doesn't go cold the moment you stop microwaving it. Same logic. So, no dramatic freeze, no sudden blizzard, no jacket needed. Earth holds onto its warmth like a well-insulated thermos. Would Earth go off course? Here's where it gets slightly nerdy. But stay with me. If the sun stopped exerting gravity for a full second and Earth felt that drop 8 minutes later, the planet would briefly drift off its normal orbital path. Not enough to cause any real chaos, but it would shift slightly, like nudging a bowling ball mid-roll. That micro-trajectory change might be barely measurable. But multiply that over thousands of orbits and, in theory, Earth's path could slightly wobble. Now we're talking minuscule long-term orbital irregularities, but nothing instantly dramatic. What happens to the moon? You might think Earth's moon would be unaffected. It orbits us, right? But here's where it gets weirder. The moon isn't just orbiting Earth, it's part of a three-body dance between the Earth, the moon, and the sun. The sun's gravity helps keep the moon's orbit stable, like a cosmic metronome keeping the beat. When that force disappears, even briefly, the moon's path starts to drift. Its delicate balance is thrown off. And though it'll still orbit Earth, its trajectory could become slightly more elliptical. Over time, those little shifts could cause tidal chaos. We might see more intense tidal waves, irregular seasons, and, in the extreme case, a moon that slowly spirals away into space. The butterfly effect of a cosmic blink. Let's go even deeper. Even the tiniest change in Earth's orbit could shift our seasons. Winters get longer, summers arrive late. A 1-second deviation could, over decades, cause agriculture to suffer. Animal migrations could falter, the climate could subtly change. It might take centuries to notice, but the effects would echo through history, a 1-second cosmic hiccup leading to famines, floods, or droughts 100 years later, and we'd never trace it back to that single moment the sun blinked. What if it disappeared for 5 seconds? Okay, let's get a little wild. What if the sun disappeared for not 1 but 5 seconds? Still, no visible change for 8 minutes. Still, the Earth's warmth holds. Still, plants carry on. But now that gap in solar wind protection is longer. More radiation might sneak through. Satellite systems would definitely notice this time. Small-scale malfunctions, potential GPS errors, even disruption in radio communications. Birds might act confused. In Kenya, during a solar eclipse in the 70s, wildlife got visibly disturbed. Zebras panicked, birds went silent. The air cooled noticeably by 4 to 5 degrees Celsius in just a few minutes. That was just a natural eclipse, a simulated night, not even the sun vanishing. So animals, they might get spooked. The 1-week nightmare. Now let's get terrifying. If the sun vanished for a full week, even temporarily. Welcome to a slow-motion apocalypse. First 8 minutes. You still see the sun. Life feels normal. Then, blackness. No sunrise, no sunset, just pure night. City lights flicker on. Rural areas drown in dark. Temperatures start to drop, not instantly but gradually. Within days, frost creeps in. By the end of the week, Earth's average temperature plunges to -17 degrees Celsius or 1 degree Fahrenheit. That's still survivable, but barely. No sunlight means no photosynthesis. Plants stop producing energy. Crops stall. Herbivores begin to starve. And very soon after, we do too. After a full year without the sun, Earth's surface hits -73 degrees Celsius or -100 degrees Fahrenheit. Most of life, as we know it, is gone. Without the sun's gravitational grip, the entire solar system starts to fall apart. Earth flies off into space, random, directionless, possibly crashing into Jupiter, or a rogue planet, or a starless eternity. So, are we safe? So when the sun vanishes for just 1 second, thankfully none of that happens. No ice age, no instant death, no orbit-breaking catastrophe. But it's not entirely harmless either. In that tiny blip of time, we get a glimpse of how fragile our systems are, how dependent we are on something we never think twice about. The sun doesn't just warm your face, it shields satellites, powers photosynthesis, fuels weather, controls gravity, and holds everything in place. And for 1 second, it can make you think, what if next time it doesn't come back? A sneaky revelation. Here's a trippy thought. If the sun could disappear for 1 second, it would probably violate the laws of physics. Stars don't just blink out. If something removed the sun instantly, it'd take infinite energy, or technology far beyond what we understand. It would mean breaking causality, rewriting space-time, warping gravity. So maybe the scarier question isn't what happens to Earth, maybe it's what or who could make something like that happen in the first place. You don't need the sun to vanish for a week to understand how important it is. Even 1 second is enough to show you how interconnected everything is. Light, heat, gravity, radiation, life. One glitch in that system, one flicker, and the consequences ripple outward in ways we're only beginning to understand. If something as massive, ancient, and consistent as the sun could blink for a second, what else are we assuming is permanent that maybe isn't? Because in a universe this strange, maybe nothing is truly forever.